Okay, guys, I'm very glad I have received the comments that the video is clear, so that's why I'm gonna keep going. Again, there's gonna be a background noise around me because of my kids. But I'm gonna pick up from where we left off, which is identity number 9, and it's a very important one, so that's why I put a star on it. It's Pythagorean identity because it has the relationship of a Pythagorean theorem and a right triangle, as we have explained. And there's so many identities that derive from this one. So if you understand this one, you'll be able to understand all those. We said this one derived from it if we subtract cosine squared on each side. This one derives from it if we subtract sine squared on each side. Now, we got to number 12, and number 12 identity includes a tangent. So how do we get tan? We know that tan is sine over cosine. That's why what I did is I took this original identity, which is the star one, and I divided everything by cosine squared. So if you divide everything by cosine squared, since this is an addition, so we divided everything by cosine squared. We kind of split the common denominator. And now it's cosine squared over cosine squared is 1. Sine over cosine is tan. But because both of them are squared, so it's tan squared. 1 over cosine squared is secant squared. So this is an important one as well. We have this last one if we divide by sine squared instead, and again we're always taking the original one. So if we divide by sine squared, we get cotan squared plus 1 equals cosecant squared. And if you look at it, you can actually see the connection. Instead of tan, we have a cotan, the reciprocal of it. Instead of secant, we have the cosecant. Okay, so the boxed ones are important as well. And this is just explains how we can get them from the original one. So now we are on a new set of trig identities. And everything new might sound confusing, so I don't want you to be overwhelmed or to worry about it. I just want you to try your best to understand as much as you can now. So if you see all of those have a pi over 2 in them, and pi over 2 means 90 degree, and theta is any angle. So basically we are talking about complementary angles, and complementary means they add up to 90 degree, which is that pi over 2 right here. So I took an example in a triangle, in a right triangle, because this is where we apply sine, cosine, and tan, and all those trig ratios. I took the example 30, 60, 90 because this is the most familiar and the nice one. This is a 1, this is a 2, and of course you can find the other side of the triangle. So if we're talking about cosine, the cosine of 60 degree is adjacent over hypotenuse, so 1/2, so 1 over 2. And if we're talking about the sine of 30 degree, it's opposite, so 1 over hypotenuse, which is 2. So half. So you can see that the cosine of 60 is the same as sine of 30. And this is where that comes from. Cosine and sine of complementary angles are equal. So even if I had right here 20 and 70, even if we had 25 and 65. So all this, any two angles that add up to 90, the sine of one is equal to the cosine of the other one. So this is what this identity is explaining. The sine of pi over 2 minus theta equals the cosine of theta. In other words, the sine of an angle is equal to the cosine of its complementary one. If you add up pi over 2 minus theta and theta, they add up to pi over 2, which is 90. And I'm going to do it here to clarify. Pi over 2 minus theta plus theta. So adding up those two angles, those cancel out and you're left with pi over 2, which is 90 degrees. So those two angles, this is one angle, this is another angle, we call them complementary angle. So now you can see the sine of one is the cosine of the other. The cosine is the sine. Tan becomes a cotan. Cotan becomes a tan. Secant, cosecant, and cosecant, secant. So if you just memorize the top one, which is number 14, you can get all of these from it. So sine, cosine, switch. Tan, cotan, and switch. Secant, cosecant, and switch them. Okay? Now, odd, even, this is even more simple. I just want you to memorize that two trig functions are even and the rest is odd. That's how I want you to record that in your memory. So the even ones are cosine and secant. And just a review, we already talked about cosine being even. Just like the idea of a parabola, quadratic. That's why I linked it to quadratic. Quadratic function is even, which means if I do 2 squared or negative 2 squared, I get the same output. So opposite input, same output. So that's why the cosine is similar. So if I say cosine of 60 degree or cosine of negative 60 degree, those two angles have the same cosine. And I'm gonna just remind you, we did the unit circle, and I'm gonna take 60 degree, which is pi over 3, and I'm gonna take the negative 60 degree. If you guys remember, going clockwise will give you the negative radian. If you do the coordinates of these, it's half square root of 3 over 2, and this is half and negative square root of 3 over 2. So if you see, the cosine stays the same, but what happens to the sine will be opposite. That's why we say the cosine is an even function and the sine is an odd function. Okay, so just memorize the even, the angle and its opposite, they both have the same cosine, secant as well. But for all the other 4 functions, it becomes negative. Just as the example we took here. So sine of 60 degree is the opposite of sine of negative 60. So if I were to write it here, sine of 60 degree and a sine of negative 60 is not the same. They're opposite. Versus cosine of 60 and cosine of negative 60, they are the same. Okay? So this is what this part means. And I'm gonna record a separate video for the sample problems.